All right, welcome to week 2, part 1. Last week, in the final section, part 4, we introduced the idea of list objects, which you can define by specifying a sequence of values in square bracket characters separated by commas. So here M is a list of 3 items. We saw a variety of operators like plus for concatenation or times for repetition, and we also saw named operations like m.append or m.sort, and we saw that you can access items within a list either forward or backwards. So m sub 0 is the initial item in the list. Let me redisplay m so that we can see it. So m sub 0 is the initial item. M sub 3 is the final item, counting forward. Now counting backwards, we can say m sub minus 1 to start at the end, down to m sub minus 4, which is the initial item. And if we go outside the bounds, for example, if we try to access m sub 12, we get yelled at, or m sub minus 5, we get yelled at. We introduced the idea of physical and logical lines. We saw that you could extend a logical line across multiple physical lines by doing things like using a backslash character or parentheses. All right, so in each of these cases, I've successfully defined a variable x referring to the value 45, and I've typed the logical line, the statement that creates the variable x and causes x to refer to a value, using the backslash and then using the parentheses. We took a look at using the for loop to step through all of the items in a so-called iterable. All right, so here we have displayed each of the items in the list M, one per line, and we looked at the range function that is an iterable in which we can give an initial value as the first argument, one past the final value as the second argument, and if we wish a step size as the third argument. And here I'm printing the value of I and also the value of I squared. For I going from 10 up to but not including 20 with step sizes of 3. So 10, 13, 16, 19, and 19 will be the last value. And there we are, so the values on the squares. In this first section of week 2, we're going to take a look at what are called slices of sequences. A list or a stir or the range, for that matter, is an example of a sequence. And we'll see how we can get pieces of a sequence using what are called slices. We're also going to introduce the idea of object ID, which is a unique identifier for each object that you have in your program. Object, how did I do that? Okay. Oh, I must have hit the edge here. Okay, sorry about that. So an object is simply some chunk of memory that contains a value or a collection of values. So 5 is an object whose value is 5. 1, 2, 3 in square brackets is a list object containing the items 1, 2, 3, and so forth. All right, so onward ho. Let me define ages as shown here in this example. These are, let's say, ages of maybe family members All right, so we've got 5 family members here, 3, 12, 5, 33, and 86 are their ages. And we know that if I just ask for ages, I get the entire list. If I ask for a sequence or a subsequence by using square brackets, this is what's called slice notation. And I can come back here. All right. And I can get a slice of any sequence, such as a list or a stir or a range. So ages sub 0:3, let's say, means that I want a slice that is a sublist of the ages list that includes items sub 0, sub 1, and sub 2. But as with the range function, that second value there after the colon is the index that's 1 too far. So we're going to get items sub 0, 1, and 2, but not up to, but not item sub 3. So the slice that we're going to get from ages here is just the slice through till 15. And a slice of a list is a list. Okay, ages is a list, a slice of a list is a list. If I do this with a string, if I say HELLO, that is also a sequence, and so I can do slicing on it. Actually, I don't believe I've shown you that you can do individual subscripting in a string, but you can. So hello bracket 3 is the second little l in that string, HELLO. That second L is item sub 3 in the string. And if I want just part of that string, a substring of that string, I can say something like, oh, let's say 1:3. Okay, so item sub 1 is this E. Item sub 2 is the first L. Item sub 3 is the second L, but the second L is not going to be included in the slice. So L, namely the little E followed by the L, is that slice from that string hello. Okay, so ages sub 0 through 3 gives me the first 3 items of the ages list. Ages sub 3:5 gives me the last 2. Here's ages, and I can say ages sub 3:5. All right, so ages sub 3 is this item, 33. Then we have ages sub 4 is 68. Now, there is actually no ages sub 5 item. However, the 5 in the slice is the index that's 1 too far anyway, so I can successfully ask for ages sub 3 through 5 and get items sub 3 and 4. All right, now I know I can't ask for the individual item ages sub 5 because that's not a valid index within the ages list. But I can use 5 as the 1 too far index for the end of my slice. Okay, so 2 through 5 is going to give me sub 2, sub 3, sub 4 in a slice of the ages list. It turns out that you can leave out the first index in a slice, and the implication is that you mean 0 if you do that. So here's my ages list, and if I say ages sub 3, that's equivalent to saying ages sub 0:3. And it means to get me a slice from the ages list containing items sub 0, 1, and 2, up to but not including item sub 3. All right, so again, that's the list 312.5. Similarly, if the second index in that sequence specification, that slice specification, is missing, the implication is that you mean all the way up to the end of the sequence. So if I say ages sub 2 : that's the same as ages sub 2:5, and what I get is all the items from item sub 2, 3, 4 up to but not including item sub 5. Okay, so that's very common to leave out the initial index or the final index. In fact, you can leave both out. If I ask for ages sub and then just type a colon, this is the same as ages sub 0:5. And what it gives me back is a slice that is a copy of the original list. Okay, so that gives me back a copy of ages, which is 312.5, 3368. Now, you can append one list to another list using the plus operator. So here I'm creating, let's see, let me do a copy and paste here so I don't have to manually type in the definition of this list A and risk making a silly mistake. All right, so there's my list A, and what A consists of is the first 4 even numbers starting from 0, followed by the first 4 odd numbers starting from 1. So 0, 2, 4, 6, 1, 3, 5, 7. And if I ask for A sub 4:, well, A sub 4:, means from item sub 4, which is the 1, up to the end of the list, 3, 5, 7. All right, so that's that first slice is the 1, 3, 5, 7. A sub 1:4, on the other hand, is the sub 1, 2, and 3 items. Okay, so starting from the sub 1 item up to but not including the sub 4 item. So that's going to get me 2, 4, 6. And if I use a plus between two lists, that will get me a list. A sub 4:, colon, plus A sub 1:3. I get one slice of A and another slice of A, and I'm appending the two slices together. So I get the 1, 3, 5, 7, and then I get, well, I get 2, 4. I had meant to say 1:4, but I typed a 3 by accident. Let me correct that. Or, I mean, it is correct, but it's not what I was meaning to do. Okay, so that's what I was meaning to do. I've got the last 4 items from the list first, and then appended to that or concatenated to that, I've got these items 2, 4, 6. Okay. Similarly, I can ask for a slice of a string. So if I have hello, and I ask for a slice, :3, well, :3 is going to mean HEL. Those are items sub 0, 1, and 2. That is up to but not including item sub 3. And to this, I can append another string, P!. The result is a string help! And this final one here is another, well, third one, excuse me, is another example involving a string. I like to use the word international because there's so many interesting things that I can pluck out of it. So S1 is the string international. S1 sub. Now, -2 is the index of the second to last item in the string. Okay? So -1 would be the index of the last item in the string. -2 is the index of the second to last item in the string. So if I ask for the slice, -2 colon, that means give me the A and the L. It is, give me starting from the little a all the way up to the end of the string. So that slice gives me AL. And then this next bit here, S1 sub 2 colon 8, well, let's see. S1 sub 2 is going to be the T here, and 2 through 8 is therefore going to be 2, 3, 4, 5, 6, 7, but not 8. Okay, so I go up to but not including item sub 8. So I've got turn at for that part. And then S1 sub 3 colon 4 is ER. Okay, so S1 sub 0, 1, 2, that's the INT, and then 3 and 4 are, whoop, pardon me. I made a mistake. Okay, so by saying 3 colon 4, what I'm doing is getting a slice that's actually only one character wide. I'm saying give me item sub 3 up to, but not including item sub 4. So it is a slice, but it's a slice that's only one character wide. Nevertheless, because it is a slice, I can use it in a concatenation statement. So if I do this all together, S1 sub -2 colon, colon, not semicolon, and then append S1 sub 2 colon 8, and then append S1 sub 3 colon 4, and close but no cigar. Let's try that again. I said A1 by accident instead of S1 at the end here, so let me say S1. And there we are. So now I have extracted the word alternate or alternate out of international by plucking out various slices and rearranging those slices. Let me point out something that's important to know. If I have a string hello, I can append another string to that by using the plus sign. Let me say comma world. And I end up getting one string consisting of hello, comma, space, world. Now, if I have a list, here I have a list M, 1, 2, 12, 43. I can append or concatenate another list just fine. So if I have a list and I append a list, I get a list. But I can't append an individual value. If I say M plus 3, I get yelled at. You can only concatenate a list to a list. How could I append a 3 to the end of the value of M? Well, to do that, I could just create a list of one character. Pardon me, a list of one value. So if I say M plus a one-item list containing 3, then that works fine. Now, this does not modify M. It simply takes a copy of M, and to that copy of M concatenates this list, or a copy of this list 3, to give me back this list 1, 2, 12, 43, 3. Okay, now it turns out, and this is really cool in my humble opinion, you can also use range with slices. So range is a sequence, and if I say range 10, I'm going to get back that range 10 is equivalent to range 0, 10, because the values in that range go from 0 up to but not including 10 with a default step size of 1. Now, if I take that range and ask for just a slice, let's say from the 5th item to the end, I should say from the sub 5 item, that's actually the 6th item to the end, the cool thing is that the range function will figure out that this is itself a range in which the initial value is 5 and the final value is 1 less than 10. So this is going to give me the values from 5 through 9. Okay. So list, string, and range are 3 examples of what are called sequence data types in Python. And if you have a sequence, you can request a slice from the sequence using the square bracket and colon notation. Next up, we're going to take a look at the concept of object identity. Just about anything in Python is an object. That is, it occupies some memory, it has a data type associated with it, and there are operations that you can do on it. And this includes not only the low-level types int, float, bool, stir, it also includes list. For that matter, it includes a function like print or a function like len in Python is an object. A class, which is a user-defined data type, is also an object, and there are a variety of other objects. Now, you can tell different objects apart from each other because each individual object within your running Python code has an ID assigned to it. So if we take a look at this list m that we have, I can ask for the ID of m, and I get back this unique number. M is the one and only object in my running Python environment that has that ID number. I think I have an N sitting around. Nope. Maybe an S. Nope. I was looking for another variable that I have. Let's see. Let me scroll backward here. S1. There we go. S1. So I do have an S1. And if I ask for the ID of S1, I also get some number. And there isn't any real inherent meaning to these numbers that you can make use of in your code, but you will observe that the ID of the object S1 and the ID of the object M are different. All right. Now, even literal values have IDs in Python. So I can ask for the ID of 7, and I will get a number displayed. And I can ask for the ID of 12.56, and I'll get a number displayed. I can ask for the ID of hello, and so on. So each of these objects has its own unique ID. Now, a variable in Python is a reference to an object. A variable itself is not an object. A variable is simply a name for an object. So it turns out that if I look at the ID of 7, and I see that it's this number, and then I say x gets 7, what that actually means is that the variable x has been created, and x refers to 7. When I ask for the ID of x, I'm not actually getting the ID of the variable x. What I'm getting is the ID of the object to which x is referring. So I'm going to get the ID of 7, which is that same number. And if I say y gets 7, then the ID of y is also going to be that same number. It's possible for items to be equal in value, but without having the same IDs as each other. These sequence types, lists, strs, ranges, and so on, can have equal values, but not be literally the same object. If I say m gets, and here I'm redefining the variable m to refer to a different list now. I'm going to create a list containing the items 1, 2, 3, and m refers to that list. Okay. If I now say n gets 1, 2, 3, well, m and n are variables that refer to objects whose items are the same, that is, are equal to each other. But if I ask for the ID of n, I get a different number than the number I had previously gotten for m. Why does that matter? Well, let me say m dot, well, let's first display m and n to remind ourselves what these lists currently contain. And now let me say m dot append, append, I don't know, 13, and n dot remove 2. Well, I have independently modified m by appending 13 at the end, and modified n, or I should say modified the list that n is referring to, so that 2 is no longer in there. And yet, all right, now the ID of m has scrolled off the top of my window. Here's the ID of m, 278, blah, 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 168. And if I ask for the ID of m, I get 278, blah, blah, 168. So the ID of m has not changed. It is the same list, but I have modified the items contained within the list. Likewise, here's the ID number for n, 278, blah, blah, 784. And its ID number has also not changed, 278, blah, blah, 784. On the other hand, if I say n gets m, that does not create a separate copy of that list m. All right, m is referring to this list 1, 2, 3, 13. N is actually referring to the same list now. That is, this assignment statement says, modify the variable n, or create the variable n, to refer to the same object that m refers to. That is, to refer to the same list that m refers to. And so if I ask for the ID of m, I still get 278, blah, blah, 168. And now n is referring to that same list. So if I say m dot pop and then look at n, I will see that even though I did the pop of the final value 13 from that list that m is referring to, if I look at that list through the name n, I see that it was changed. Okay. Now, the double equal sign is what's called the is equal to operator, or is equal in value to operator. So if I say, let me redefine m to refer to 1, 2, 3, and n to refer to a different list also containing the 3 items 1, 2, 3. At this point, the ID of m and the ID of n are different from each other. However, m is equal to n. When I test this expression, m is equal to n, that's going to be true because the list that m refers to has the same number of items with the same values as the list that n refers to. Now, as an alternative to is equal to, another test you can perform for identity is literally the word is, okay? So the word is an operator that tests whether these are literally the same object. That is, does M refer to the same object as N? This is false. All right, so we've now taken a look at sequence objects, including strings, lists, and range functions are actually sequence objects, and we can get slices of all of these things. We've also taken a look at the ID of an object, and each object in your running Python environment has its own unique ID number. If you request the ID of two different variables, M and N, let's say, and you discover that those IDs are the same, that actually means that the variables M and N are referring to exactly the same object as each other. But if the ID numbers are different, then when you request to see the IDs, they will be different. So you get a little practice with this in the lab for this section.